we have just under an hour for a brief introduction to capturing and analyzing network communications. This session is going to consist of a short overview of the topic area and then some hands-on work. For that hands-on work, you will see that the slide deck has screenshots, commands to execute, and sample output. And to be very upfront about it, it's actually a bit more than I really expect to get through in today's session. I wanted to leave a little bit of extra in there and plenty of stuff for people to work through on their own time if you were so inclined. So I'm going to walk through the commands to get everybody started. I will demonstrate it, and absolutely you are free to follow along. I encourage you to do that. But you can also just listen in and work through the go through the work yourself later, and feel free to reach out if you have any questions. To that end, in the footer of the slides, and actually it's in the footer that's on the slide that's on screen right now, there is a bit.ly link for a copy to this deck and also my Twitter handle. So you can feel free to reach out to me directly that way. You can pull down a copy of the deck as well as the version that SANS is going to make available. But that bit.ly link is active right now. And of course, the other channels that Lee and others have mentioned to communicate directly through SANS. So lots of options there. And just to make sure that everybody knows I'm not trying to pull one over on you, I'm not going to rickroll you. If I open up my browser, move it down to the screen here, and actually go to that link myself. Of course, I've just obfuscated my view of it while I'm typing because of this. 3.1. I should have just copied and pasted it in to begin with. 3.1xiyNC. 3.1xiyNC. Should do it. All right, so now hold on one second because I'm going to flip screens and just copy and paste directly from my deck since I'm mistyping something. Here we go. Oh, yeah, had a typo in it. Yes, so you can see that that goes directly to that Google Drive presentation, pulls that up. You can pull that down and look at it and follow along if you would like that way. But getting back to the actual presentation here, the workshop requirements when you go through the work, whether it is today or later, here are your basic system requirements. It's pretty straightforward. You need to be able to browse the web, run commands as root or administrator on your system, and have those tools listed there installed: tcpdump, Wireshark, and tshark. Now that's already set up on the Cybercamp's Kali VM. So if you have that and it is working for you, if you pull down later, that's fine. You could also do all of these same exercises yourself on your own system as long as you meet these basic requirements. We're not going to do anything super uber high tech, so there shouldn't be any issues. Mac, Windows, Linux, whatever your preference is, should be just fine. Now, as far as my path into cyber is concerned, basically, I grew up out in the middle of nowhere, about a 5-mile bicycle ride into the nearest town of 300 people, and it was really, really boring. So I worked summer jobs to earn money, lots of dishwashing gigs, and there wasn't really anywhere to drive to anyway. So instead of buying a used car, bought some gaming consoles, some low-end computers, really cutting-edge stuff, 32K RAM, tape drive, the works. Eventually graduating into slightly better systems, writing my own programs, having a internship, which in my case meant cheap labor for a company that wanted somebody to read encryption algorithm specs and program them in C and assembler. So, yay capitalism. Eventually enrolled in college, worked jobs there in computer labs, moved on to professional programming and network installation jobs. Eventually, I gravitated toward security and information assurance. And the reason that I did that is because it can be challenging, right? You're talking about, different types of cyber work, red team, blue team. Blue team, defense, information assurance can be hard, and hard problems are fun, and it's fun to solve problems that are interesting and have lots of facets to them. And in fact, in my day-to-day work, I've had a couple of people ask me before, including my wife at one point, what exactly it is that I do for a living. And I had to think on it for a few days, and I came back and I said, well, basically what I do is I solve problems, and sometimes they're technology problems, sometimes they're process problems, a lot of times they're people problems, but really that's what we're there for, is to solve problems and to help whatever organization that we're supporting to operate and meet their objectives in as secure a fashion as we can. And really that's what it's all about. So enough about me. Let's go ahead and get into the workshop itself. What is packet capture analysis? What is it that we're actually talking about here? It's intercepting network communications, decoding it, interpreting it. Whenever you're on a PC or your phone or some sort of IoT device and you're communicating with some other device besides your PC, and actually many times when you're even communicating with your own PC, it's using network communications. The bits and the bytes are being packaged up, they're going across the medium. It might be wireless, it might be wired medium. It's being reassembled on the other end, translated, and then acted upon. Intercepting that network communications means grabbing it in between point A and point B, figuring out what it actually means and getting useful information out of it. There's some examples on screen here: a web client to web browser, or I'm sorry, a web client to web server, the application going back to its database, your DNS client when you type in a name and it gets resolved to an IP address, or vice versa, going out to a DNS server and the response coming back. Even on your local area network, when you're printing something to a network printer or accessing a file, that's network communications. And there is an opportunity there for us as security professionals or IT professionals, or even just people dabbling in it, to look at it and get meaningful content out of it. And you should care about this, because if you end up working in IT operations, IT security, ultimately you're going to need to have at least a basic understanding of how network communications works between these two hosts, between the different hosts in the environment. And if you have that basic ability to do some of that analysis and really understand what's going on in your network and what the communications really means, you will be far and away ahead of the people that don't have that understanding, who just think that it's magic, right? They type something and it flies through the ether and ends up on the other side, mysteriously reassembles. You'll have an edge and a leg up on it. So definitely you want to know what's going on. And it's cool. It's just cool to understand how it actually works together. Now, how this actually works in practice, how we intercept the data, there's multiple methods for that. If I am on a wired network, say Ethernet or fiber, and I have two hosts on opposite sides of the room that are communicating with one another, there's a cable there. And I can put in something called a network tap. And what the tap does is it basically sits in the middle of that cable. Instead of having one cable going from host A to host B, now I have a cable that goes from host A to the network tap, and another cable that goes from the other side of the network tap to host B. And that means that if I have control of that tap, all the communications flows through it. I can grab a copy of it. I can pull it off to the side and then start working with it. Another way that you can do that is with a switch, right? Usually we don't have two computers that are just directly connected to one another via a single cable. They go to a device called a switch. Old school would be a hub or a MAU, and that device in the middle is responsible for moving the packets at that low layer between the different hosts on the network. And if you have a relatively modern switch, like say pretty much anything produced in the past 20 years, you're likely to have the capability to have something called a mirror port. Basically, the switch is just configured to say, hey, whenever a packet goes across, or a frame goes across the wire between this port and that port, or this host and that host, make a copy of it, send it out this other port, and that's where I have my network monitoring system listening to that. And again, now I can start interpreting it and analyzing it. Now, those are the two methods that you would typically use if you're on the good side of things. If you're on the defensive side, if you're monitoring things and protecting your environment, or just trying to monitor what's going on. There are malicious ways to get copies of the data. You can trick individual host or network gear into sending, as an attacker, sending us the traffic. That is a whole session in of itself. We could spend days just talking about that. So for here, just be aware that it can happen. There's also wireless monitoring. Now, the first two examples I gave of taps and switches, that depends on you having physical cables, a physical device, something that you can configure or sit in the middle and grab that information as it traverses the wire. But with wireless communications, it's just in the ether. It's just in the air. All you have to do in order to grab packets for wireless monitoring is to be within range. And that basically just means that you have to be willing to invest enough time and money maybe into having a really, really good, high fidelity, good quality antenna. And hopefully that your target has not implemented like a full-on Faraday cage to block all electronic signals and emanations from their environment. But usually it just means being within range or sitting in the parking lot across the street. And then the last method, and the one that we'll actually use today, local host intercept. That's the bare bones version. I'm on the host that is communicating with somebody else or other devices. And clearly that host, my workstation, is able to see all of the communications that it sends and receives. So if I've got software that is running on that host, then I can just grab the packets as they come in and as they leave. And that's what we'll use again with our examples today and the different tools we're using. But keep in mind, the techniques that we're using are still going to be applicable for the most part, regardless of how you're actually getting the packets, right? We're going to talk a little bit about getting the packets, but our main focus is what do we do with them once we have them. The core tools we're going to look at: tcpdump, Wireshark, and T-Shark. As you move up that stack, you get a little bit more fancy, a little bit better capabilities. tcpdump is a basic packet analysis tool. When you send data across the wire, it gets packaged up in packets and frames. So when you hear people talking about, hey, I'm doing a packet capture and I'm looking at packet number whatever or this frame, what they're talking about is that electronic version of the data, the ones and the zeros, that has been sent out across the wire so that the other host can decrypt it or decipher it, can unencode it and use it. tcpdump is able to do some basic capture of those frames or packets as they go across the wire and some basic analysis. It doesn't get real far down into the weeds. It can't extract files from the communications, anything like that. But it's very, very efficient. It's very, very fast. And it is absolutely worth your while to know how to use this tool. And that's where we'll spend the majority of the time today, because it is everywhere. If you are on a Linux host, a Macintosh, a firewall, a load balancer, a Cisco router, Cisco switches, Juniper devices, all these kinds of network infrastructure devices, very, very, very often you will find that there is a version of tcpdump that is built into that device because it's so lightweight and it's so easy to use. So you could be on a switch or a router on your network and use tcpdump or equivalent to pull some data off, do some basic filtering on it, save it, extract it, send it over to your analysis workstation, and then do some more in-depth analysis there. So you want to be familiar with this tool if you're going to be doing any sort of network analysis, because you'll see it all over the place. Very, very useful, and it's fast. It's very fast. And the next tool is Wireshark. Wireshark is a protocol analyzer. Now, tcpdump, I said, just basic packet analysis, a little bit of information it'll decode and present you with useful pieces of information. Wireshark understands all kinds of different protocols, all the way from IP, the Internet Protocol, up to HTTP, HTTPS, DNS, SMTP, all these different protocols that you may have heard of that get used when you're communicating on an IP network. And it can actually understand the guts of those protocols. And so it can give you helpful information and decode it for you and say, oh, you're looking for the SSL certificate that was associated with this communications with this web server. Here you go. And it just presents it to you so that you don't have to get out your calculator or a piece of paper and a pen and paper and calculate the bits and bytes to figure out exactly what part of that bits and bytes represents the SSL certificate. It just gives it to you. That's really, really cool. And then T-Shark, the last tool here, is actually it's part of Wireshark. You can install Wireshark without T-Shark, but usually they get installed together. It can do everything that Wireshark does, but without the GUI. So it's a command line version of Wireshark. It does all that same sort of protocol analysis, really, really gets into the details of the communications. But because it's on the command line, you can use it for automated tasks, for scripting. You can use it for data analysis, where you need to have like this huge volume of data that is sent across and pull out some specific packets here and there. Sorry, hang on one second. I just saw a note come across. Okay, just wanted to make sure that I wasn't missing somebody telling me that the audio or video was cutting out. All right. Oh, and then the last thing, libpcap or winpcap. When you're using a tool like tcpdump, Wireshark, or T-Shark, these are actually the tools that interpret the information, that decode the information that you pass to it. Technically, they're not actually the things that are pulling the packets off of the wire or out of the air in the case of wireless communications. The two most common examples of the things that do that are libpcap and winpcap. Those are the things that are actually interacting with the kernel, working with the network card to grab the packets and then present them to tools like tcpdump, Wireshark, or T-Shark. So you can use those other analysis tools if you've just got a file that you want to work with that you've already captured and you want to analyze. But if you want to do live capture on a host, you need to have libpcap, winpcap, or equivalent installed. And again, it is installed on the Kali VM. And if you install on your own system tcpdump, the Windows equivalent, WinDump, or Wireshark, you'll get prompted to say, do you want to install this? So that's the main reason I wanted to cover that here. If you're doing this on your own system and you see that it says something about a capture library, that's what it's for. Okay, that's the brief overview. I'm keeping half an eye on messages in Slack, and then Lee will let me know if anything comes up in the chat or Q&A that you need to respond to. But let's switch over to the hands-on piece. Again, if you have the deck, then you'll see screenshots like this that kind of give you step-by-step instructions of moving through things. But what I'm going to do is I'm actually going to switch over to my Kali VM, and I'm just going to start working through this stuff and testing it out, following the same steps that I have in the deck. So let me switch over to the Zoom, and I need to change my sharing, I think. And this will be my first technical hurdle of the day. Stop video, new. Oh, there we go. I'm going to pause my share. And now I need to switch screens. There we go. And now come back and sorry for the hold up here, a little bit of a technical difficulty right now. Okay. And start the share again. share screen number 2, share. Great. So now you should actually be able to see my full screen there. Lee, quick confirmation. Can you see the Kali VM now?
I can.
Okay, great. So let me go ahead and log in here. This is actually the exact same VM that was made available to everybody else for the cyber camp. So you know that it's going to work. I'm going to go through the same steps as I would have everybody else do if you were doing this yourselves on this system. So I'm logged into Kali. The first thing I want to do is I want to kind of get a lay of the land. I want to look around and see, well, what's on this system. If I'm going to start capturing packets, I need to know what network interfaces I have and how they're set up. So I'll open a terminal prompt, and there's a couple of different ways that I can do this. The first command that I could run is called IP, and it has different options on it. In this case, IP address will give me a list of the local interfaces on this host and the IP addresses associated with them. So you can see I have 1, 2 interfaces. The first interface is LO, that is an O, not a 0. It stands for loopback. That's the interface that I would use if I wanted to have my host talk to itself. So if I want to talk to myself, then that would be great. If I want to actually talk to anybody else, then I need to use this second interface called ETH0, which has an IP address here of 192.168.48.151/24. Now, amusingly enough, when I wrote the slides, I did screenshots, and I noted on the slide deck that your IP address might be a little bit different. It depends on how you have your virtual machine environment set up, what software you're using. Maybe you've got other hosts on this same virtual network. There's different reasons that you might show up with different IP addresses, or even an entirely different network. You're not even necessarily going to see the 192.168.48 network. When I did the screenshots, my IP address is 150, now it's 151, so it has changed. When you see that, that's okay. You will expect to see a little bit of different variances between what I'm showing you on screen and what you'll see for yourself. The key thing is, do the commands work, and they give us the type of information that we expect to see. Okay, so don't be worried if you see a little bit different information. Now, if I wanted to, other commands that I could work with here, there's another command called ifconfig. That's the kind of old school version of the IP address command. Shows me very similar information. And again, same IP address, same network mask, so I know I'm on the same network. If I wanted to then figure out, okay, who all can I communicate with? What are the different networks that I'm connected to? The next command that I might run is IP space route. And that tells me what networks I'm directly connected to and how I get to them, which interfaces I use, and what my gateways are, what the next device is that I might route through to get off of my local network. And in this case, I have just one route available to me. It's my default route. Everything that I send out on the wire that goes anywhere except for my local network is going to go out ETH0. That's the interface that we saw before. And the next hop is going to be this 192.168.48.2. That's the gateway, or the next hop router. Now here, this is very simple. It's very straightforward, because we're on a virtual machine system that has a very basic configuration. But if I were on a live system, I was on a router, I was on a Linux system that was acting as a router, a network appliance, I could see a half a dozen or more interfaces listed and a whole lot of routing table information listed. So it's useful to look at this when you get on the system and orient yourself so that you know what you're looking at, and make sure that when you say, oh, I'm interested in traffic between me and this other host out on the internet or on another network, that you know which interface it's going to go out. Because when you run the commands to do tcpdump or tshark or wireshark, you need to tell it which interfaces you want to listen to. So as a final test, what I'm going to do is I'm going to run a command called traceroute, and I'm going to send a packet out to, let's say, 8.8.8.8, which happens to be the IP address of one of Google's DNS servers. And I'm going to see what it tells me. I'm going to see a line that says my next hop, and then I'll see a bunch of failures probably. What I'm really interested in is that next line. What I expect to show me is that it is going out via that 48.2 address, and then I know ETH0 is the interface that I'm interested in monitoring. Oh, and I see, oh, permission denied. I don't have access to that. That brings us to another point that you might run into when you are working on a Linux system and on your Kali VM. You're logged in as a regular user, right? If I were to look at my user information, the ID that I have, my username is Kali and my user ID is 1000. Well, on Linux systems, there is a root user or a super user, and some commands, because they're considered to be potentially dangerous or because they have to do things on the system that require extra permissions, are restricted and they can't be accessed unless you are running as root. So what I can do is I can run sudo, which stands for super user do. Yet it's sudo, I'm going to do something as the super user, and then the command that I want to run. The first time that I run sudo, and actually at regular intervals because this times out after a while, it'll prompt me for the password associated with my current account. I type that in, and now it runs, and sure enough, as expected, it shows me that my next hop is the 48.2, and then a bunch of failures because the intervening devices don't want to send back traceroute responses, the ICMP or UDP communications. So, okay. But the 48.2, that's the thing that I wanted to see because it tells me, yes, I am interested in looking at that 48.2 ETH0 interface. So next thing I want to do is I want to make sure I can actually talk to the internet in general, because my traceroute got to 1 hop, but it didn't give me anything past that, probably because of filtering along the way. But can I actually even browse the web? I'm going to go to the Kali menu. That's that start menu up in the upper left-hand corner. I'm just, there's actually multiple web browsers installed on Kali. The easiest one to get to is Firefox via this web browser menu option. It should start up Firefox, and there we go. It loads, but hang on. The address that it went to is this file : // That means it's actually not doing anything on the internet. It's loading something from the local system. So I need to go out to the actual internet and external host. I'm just going to use my company's my company's website as a quick test. Does it load? Yes, it loads. Because I'm really paranoid, I am going to hold down the Shift key or the Control key. I think it's the Control key on Firefox. While I click, yeah, and then Control-Shift-R will do it as well. What I'm doing there with that extra step is I'm bypassing the cache for the browser. So just in case it was loading stuff locally, now I know it actually went out and got that information from the internet, from the web. So I know I'm good to go there. All right. The next thing I might do, actually kind of coming back to this information where I surveyed the landscape, figure out what I'm looking at, I would encourage you to grab this information and save it, because you might need to refer back to the local IP address, the routing information, the network interface names, right? This is all part of network capture and analysis. You need to know what it is that you're working on, and you need to have this reference information. So what I would actually do is I'm going to grab this stuff right here. I'm going to right click and select copy. I am going to flip over to, actually let me minimize, open up. You should still be able to see this. I'm going to open up a notepad window on my physical OS on my local system. I'm just going to paste that in. Now, if I'm in the middle of doing some sort of analysis, I'm like, oh, what was the IP address again of this local interface? I don't have to run the commands again. I don't have to scroll back up and find it in the buffer. I've just got it as a reference. That's a good habit to get into when you're working on your IT systems, both for packet analysis and in general. So now, let me go ahead and flip back over to Kali. I've got that saved so I can refer back to it if I want to. Now, finally, I'm ready to actually run tcpdump. So I'm going to start tcpdump and see what happens. And the first thing it tells me is I don't have permission to capture on that device. Just like with the traceroute command, tcpdump requires some additional privileges, not for the command itself, but because it's trying to access the default interface, which in this case is eth0. So I need to, just like I did with traceroute, run sudo tcpdump, hit enter. Great, it tells me that it's actually listening, but there's nothing happening. So is it actually doing anything? Well, I need to actually generate some traffic to see whether or not it's doing what I want it to do. So I'll open up another terminal window, and because I get confused, I am going to change something here in the preferences. On this terminal window, I'm going to change the color scheme to be green on black so that I can tell the difference between the two windows, right? So the right-hand window will be the one I'm generating traffic with. The left-hand window will be the one that I'm listening on. Now I'm just going to do that same thing that I did before where I tried to get to an external host. In this case, I'm going to use the ping command. The -c1 or -c1 says one ping request, and I should expect to see one ping response. I'm going to hit enter, and lo and behold, in the background, it did in fact capture that echo request and echo reply. It also captured some other communications, right? You know, this domain PTR thing, some sort of request and response request, because I can see that the source IP address is my host response, because I can see that it's coming back from my default gateway. Okay, that's interesting. How can I filter that down and actually look at just the traffic I'm interested in? Well, you notice that it says that my ping was an ICMP echo request. tcpdump has the ability to apply filters to it. So I'm going to apply a simple filter here saying, I only want to see ICMP communications. Now, if I go back to my other window and I do another ping, that's all I see, the request, the reply. See, so at this point, I'm starting to get down into some of that analysis. I have a big ream of data that I want to go through, a volume of data I want to go through. I can filter it down and grab just the pieces that I'm interested in. And the next thing I might want to look at is I'm reading this content, and I can figure out kind of what this means. You know, is this a source IP address, a destination host? But wait a second, I'm pretty sure I typed in 8.8.8.8. not dns.google. How can I get tcpdump to just tell me the raw numbers, not this helpful translation that it's doing to host names or port numbers? Well, there is a flag that I can put on tcpdump, TAC-N, which says no name resolution. And if I run tcpdump again, go back to my other window, run that ping again, you can see that now it isn't doing the name resolution, it's just showing me the original IP address. And if I wanted to, instead of ICMP, look for port 53 communications, which is what DNS typically runs on, and then I go back to my terminal window and I force it to do some DNS communications, I can see that whereas in my previous output, I had the IP address and then this domain, .domain, now it actually has the IP address and .53, the actual port number. Now, the point that I wanted to make with showing you that, and we're right at the edge of what I thought we were going to hit in terms of time limit, so we'll stop in just a minute here. The point of that is the last thing that I wanted you to take away from this and hopefully some of the other hands-on sessions today is don't be afraid to explore. Don't be afraid to play around with the commands and check out what they can do. Particularly in this case, you're on a virtual machine. You could blow this up, completely trash it, and then just re-extract it again and start over again, right? And that's how you learn, is by testing things out, figuring out what happens when I use this command line option. And if you want to get started on that, most Linux commands support either a tac help or just a tac h. tcpdump supports both. That gives you basic options that you can use at the command line. And if you want more in-depth information, there is something called MAN, is short for the manual facility. It's manual pages. If I open up the tcpdump manual page, I've got not just that summary information that says here's the options that you can use, but it gives me a description. It tells me how the program works. It tells me what it's doing. It gives me explanations of the different options, a lot of detail. If I go all the way down to the bottom, it gives me example commands that I can run. Definitely leverage this. MAN is your friend. It is very, very useful. And just play around with this stuff, poke around and see what you can do. What happens when you try one of these other options? Like the very first option that I see here is this TAC A, right? So just last example, what happens if I run tcpdump again, but I put the TAC A, uppercase A, on the end of it, and then generate some traffic? I'll do an NS lookup again because that's, again, DNS port 53. Whoa! This is cool. It's telling me not just the information that it provided before, the basic excerpt, but it's giving me the ASCII, that's what the A stands for, ASCII readable characters that are in the packet. Now imagine I was doing this with HTTP communications or FTP communications, things that are plain text. I could be pulling out useful information such as what type of server am I communicating with? What is the browser that a particular client or host on the network is using? Is it Chrome? Is it Firefox? What version? What's their OS? I could pull out user IDs and passwords if I was so inclined, if the communications was plain text, not encrypted. So lots of stuff that you can do with this. Now, a couple of things here. To stop tcpdump, what I've been hitting is just Control-C. I know that you can't see that when I'm typing on my keyboard, but that's what I'm hitting is Control-C. Gives me a summary of the packets that were captured and that were successfully filtered out. The other thing you would have seen me doing is occasionally when I'm running tcpdump, I'll hit Enter every once in a while because when I'm doing a decode with tcpdump, man, it gives me a headache to see all this stuff all mashed together. In tcpdump, if I just hit Enter a couple of times, it'll insert blank lines, and then the next time I do something, then it shows up on a different line, so it blocks it off. So little tips and tricks like that, things that are useful, and some of that is some of those things are detailed again in the slides. Okay, so like I said, don't be afraid to play around with stuff. Check it out. If you have any questions about going through the rest of the content, you've got multiple communications channels available to you to come back through SANS or to me directly. Please don't hesitate to do that. And I think we've got just a few minutes left maybe for any Q&A. Lee?
Yeah, so there's a few questions going back here. So someone asked, where are you pulling these commands from? I mean, do you just happen to remember what these are, or how is it you know them?
Well, some of it is experience, is knowing, hey, here's the command that I use for this particular function, for that particular function. But a lot of it actually, because there's no way on the face of the earth, there is no way that I can remember and memorize in my head every command that I might want to use and every option on every command. It's just not possible. So I will point you again at the MAN page. And I said that MAN is your friend. MAN-K, which stands for keyword, is your best friend. Let's say that I wanted to look for commands on this Linux system that had something to do with packets, MAN-K packet. Here is a list of all of the commands that are installed on this Linux system that have packet either in the name of the command or in their initial brief description. If I wanted to look for a text editor on this system, MAN-K edit. Here's all the things that I can use for editing. Now, of course, some of these are going to be weird things like, browsers, editing hexadecimal content, binaries, but I can flip through those, I could filter through those and find things of interest. MAN and MAN-K, if you're not familiar with the commands, are really your best friend to play around with and find the stuff that will be helpful to you.
Awesome. And then there was a couple of questions just there about, I know this is kind of a tricky question and probably not something which you can answer very quickly, but what about capturing wireless traffic? How would you go about doing that?
Capturing wireless traffic. There are a couple of different tools you can use for that. Remember, wireless communications it's just in the air, right? It's going, and when we say wireless, most of the time, what we're really referring to is 802.11, the suite of 802.11 protocols like 802.11a, b, g, and so on. But technically, wireless can be that. It can be satellite communications. It can be 5G. It can be your other cell phone communications. In order to capture wireless, you need to have an interface, a physical interface that is capable of communicating with that physical medium, because it's wireless, but it still is a physical medium. And you need to have software that is capable of understanding the information that's being fed to it. For that, you can look at a couple of different things. The first tool that I would probably point you to is the AirCrack suite of tools, and then Kismet, K-I-S-M-E-T.
Okay. And then someone asked the question, why would you use TCP dump over Wireshark?
Because Wireshark, all of that extra stuff that it has, the protocol analysis, pulling out information, being able to do multiple passes with filters, etc., there's a cost associated with that in terms of processing time, right? CPU and RAM. It takes longer. What I would usually do, if I've got a big volume of data that I have to go through, what I'll actually do in practice is I'll use tcpdump or something equivalent to get the initial capture of information. I will probably spool that off if I have the space for it, into a file. Then I will do another pass on it with tcpdump to look for things of basic interest. Like I've got 10 gig worth of information, but I'm only interested in the DNS communications. So I'll use tcpdump with the TAC-R option. So as a quick example of that, tcpdump, let me do it this way. I'm going to do tcpdump TAC-W, and I'll use never ssl.cap. Whoops, got to use sudo. Now I'm going to open up my web browser, and I am going to browse to, hit the wrong key. That's what happens when you're using an unfamiliar keyboard. There we go. neverssl.com, I think is it. Yep. Now I'm just going to, I'm going to hit Control-Shift-R to make sure that I'm not loading cache. I'm going to close this. Now I'm going to come back to my command line, and you can see that I captured 322 packets. Nothing was displayed on screen. And in fact, if I run another command called capsinfo on that file, capinfos, sorry, what am I running into? Probably a sudo issue. Okay. I remember earlier today when Heather was saying demos. There we go, capinfos. Okay, sudo capinfos never ssl.cap. What the heck? ls never ssl. What did I do? I'll get there eventually. All right, so something weird is going on here that I have to figure out, but I've got a file here. Actually, let me do this. I've got a file here called neverssl.cap. Okay, so I don't know what's going on with capinfos, but I've got a file called neverssl.cap that I've created. If I run tcpdump on it and I now use TAC-R to read that in, I'll get everything. What? The demo gods are not shining upon me today. NR, and I ran this exact same test before. All right, so I don't want to waste everybody's time figuring out what silly thing that I'm doing, because it always turns out to be something silly. The point is that I can run the tcpdump command with the tac R reading in a file and then apply a filter to it. So if I had that file and I wanted to grab all of the port 53 communications on it, I can do that. Then on another pass, I can look at all of the port 80 communications. And then on another pass, all of the port 53 communications. And each time I do that, I can write it out to a filtered HTTPS file, right? And now, once I've got it kind of sliced and diced that way, now I'll go to Wireshark or T-Shark, which are awesome tools because they have all those advanced capabilities, but are slower. But now I've got a smaller set of data for them to work with. That's how I would actually use them together in practice.
Cool. Thank you very much. It seems like a few people jumped in and said it's never SLL.cap.
Never S. Did I never SLL? Did I type? I'm just like typing.
You did SSL. Yeah.
Let's do it this way. Yeah, okay. All right, so this is a good example, a good way to demonstrate another feature. Tab completion is your friend. So I've got never, and I just hit the tab key, and it fills out the name for me. Even though I munged it and typed it incorrectly, it populates it, and I go, oh, right, never SSL. So I'm going to read that file in. Yeah, thank you for the audience correcting me. That's great. Now, if I wanted to, I could say port 53, and it's only going to show me the port 53 communications. If I wanted to, I could say port 53, write that to never, and I'll keep with the misspelling just to keep it all consistent, DNS.cap. Now I've got that saved as a separate file. I could do the same thing where I've got http.cap, but instead I'm going to have port 80. To be more accurate about it, I should probably call it -80, because just because it's on port 80 doesn't necessarily mean it's HTTP, and there might be HTTP on other ports. But now I've got other files that I can look at. Now I can load those up in Wireshark. And be able to do more detailed analysis. Yeah, see, I did the same thing. That's okay. Now I'm in Kali, though, where I can helpfully, let me just actually type never SSL 80. There we go. Now I'm in Wireshark in Kali, and I can actually look at the guts of it. And you can see that Wireshark is, in fact, doing that protocol analysis where it's breaking it down for me. It's telling me, well, you've got a frame, it's using Ethernet, it's IPv4 is what's running over top of Ethernet, and TCP is what's running over top of that. Oh, and then by the way, if you switch to one of these other packets where it's past the three-way handshake and there's a application layer communication going on, it's HTTP, and if I want to look at the details of that, I can say, oh, HTTP, and here's all of the information inside of it. It's a GET request. Here's the user agent string. Here's the encoding that is accepted, right? And you can see that it's helpfully showing me in the packet bytes pane down here all of the hexadecimal, the underlying bits and bytes for each one of those fields.
Awesome. Cool. Well, thank you, Greg. Really appreciate your time today. And there were so many people. Whenever you have over, when you have about 1,500 people in, and like half of them all say it's SLL, there's a lot of questions I've got to go through right now. All right.
Probably had like 50% of the folks going SLL, 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 telling me.
And, it's funny because like whenever we teach classes, this is the kind of stuff which happens, and it doesn't matter how many times you look at it, it's always right in your head, and sometimes it just requires someone to point it out. So it happens to the best of us.
Which that's okay, right? And sometimes you make a mistake that's not just a simple mistake, but it's like, wow, I didn't know that did that, and you learn because of the interaction with the people on the other end of the screen in this case. So the very last thing, Lee, before I drop, because I know you've got a time constraint too, for the session overall probably, if you look at the deck and the last 2 slides of the deck, again, contact information, and then some additional resources, a book that's really good for T-shark analysis by Nick, and also referencing the man pages, and some cheat sheets from SANS. I believe those are going to be posted in the blog as well. So some good follow-up information there for folks.
Awesome.